In this video, we'll look at determining the general term in an arithmetic sequence when we're given limited information. So what we're given so far here is that the 50th term is 238 and the 93rd term is 539. We're supposed to state the general term. Well, we know that the general term for an arithmetic sequence takes the form Tn equals a plus n minus 1 times d. And so we're looking at the 50th term. T50 is going to be whatever a is, which we don't know yet. But we have this n value here we're going to use to build an equation. So in this case it's 50 minus 1 times d. And the other good piece of info is we know what T50 is. It's 238. So we know that 238 equals a, the starting number, plus 49 times whatever the difference is. We're going to find those eventually. So that's our first equation. We got it by subbing in the 50 for n and subbing in 238 for this 50th term. We'll use the same thinking for T93. We know that T93 is the starting number a plus 93 minus 1 times whatever the d value is, which we still don't know. And we know that T93 is 539. So we get 539 equals a plus 93 minus 1 is 92d. That's our equation 2. So this goes back to grade 10 math in that we have two equations with two unknown variables and we're going to solve them. There are different ways. You could use substitution, but I'm going to use elimination. That is, I'm going to subtract equation 2 minus equation 1. So let's rewrite them. Here's equation 2. 539 equals a plus 92d. And equation 2, 238 equals a plus 49d. I put a minus with a circle here just to remind myself to subtract each column. Use my calculator just to make sure I don't make any mistakes. 539 minus 238, and you get 301. So 301 equals, and here's why I did elimination. I hadn't spoken of it yet, but the beauty here is I have two a's. Their coefficients are just 1. When you subtract these equations, it's great because a minus a just leaves 0. No a's. And I'll just be left with some d's. How many d's? 92. Take away 49, which is 43 d's. And now look, I have this nice simple equation. 43d equals 301. How do you get d by itself? Divide by whatever's multiplying d, but on both sides. So what's 301 divided by 43? 7. Perfect. Now I know the difference, that is the the adding number that you're adding by each time as it goes up 7. Each step of this sequence goes up by 7. I know d. I can then sub d equals 7 into one of the other equations. Doesn't matter which one. I'll pick equation 1. So here's my equation 1. 238 equals a plus 49 times d, but I know what d is now. It's 7. So 238 equals a plus 49 times 7. Oh, typed that wrong. 49 times 7 shouldn't give me a syntax error. It gives me 343. And how do you get a by itself? Simply by doing the opposite of what's happening to a. Is a plus 343, so I'll subtract 343 both sides. And a equals 238 minus 343. So a equals negative 105. Our goal was to get the general term. So what's the general term? Tn equals, we'll use this formula, put a nice box around it. Except now I'm going to fill in the parts because I know a is negative 105 plus n minus 1, and I'll leave that. That's my variable for this equation. But now I know d. d equals 7. Some people will say you can leave the formula like this. I prefer to expand and simplify. I can get this term down a bit by saying, well, this is n minus 1 times 7, so I rainbow in that 7, I multiply it, I distribute it. 7 times n, 7n, 7 times negative 1, negative 7. So Tn equals, and I'll put the n stuff first, 7n, and then minus 105, minus 7. Don't necessarily need a calculator. Minus 105, minus 7, just to show you how to do it, is minus 112. And that's your general term formula. You don't have to, but you can also check your answer just to make sure. If that's the right formula, it better work for these. That is, if I sub in 50, I better get 238. So let's check. If it's true, T50, let's check, equals 7 times 50 minus 112. So we'll check on our calculator here. 7 times 50 equals minus 112. 238. Perfect. If it was the right formula, we should get 238. We better check the other one, though, for good measure. T93 should equal 539. So let's use our formula. 7 times 93 minus 112. What's 7 times 93? 651 minus 112. 539. And so I'm very, very sure that I'm right, because I even checked my general term formula by subbing in and got those numbers. So what I've done is determined the general term in an arithmetic sequence when I was only given limited information.